Okay, so we'll start our session this morning. So I'd like to welcome everyone here today for the second in the series of Smart Cities and Communities seminars or webinars that we've transferred over to now. So today we're going to have the Smart Energy Efficient Building webinar that is led by our very own Enable investigator, Professor Dirk Pesch, and he's going to introduce all the panelists later. Just a few housekeeping pieces. All the attendees' mics and cameras will be muted this morning. The event will be recorded. Only the presentations and the panelists will be recorded. The Q&A won't be. And please do submit your comments and questions in the Q&A on the Zoom bar below. We're hoping to keep this as interactive and engaging as possible. And we're very interested to hear what the community have to ask for the panelists. So if you've anything, please do share, and Dirk will field the questions at the end of all the presentations to the panelists. So without further ado, I'd like to pass over to Professor Dirk Pesch from
research program funded by Science Foundation Ireland and industry, which is focusing on applying the Internet of Things to a range of global challenges. It's links expertise and research output from three SFI centers: the Connect Center for Future Networks, the Insight Center for Data Analytics, and the LERO Center for Software Engineering. The idea behind Enable is kind of this feedback loop from gathering data, analyzing the data, actuating it through citizen feedback in a kind of a loop, and looking at generally at the topic around smart networks. So smart energy networks, smart urban networks, including sensors, edge computing, actuation, and so on. So it's quite a significant technology ecosystem. The benefits of Enable are that it is a collaborative research and development undertaking involving quite a range of world-class academics from a number of institutions in Ireland, in collaboration with industry. It brings in expertise in networks, communications, data analytics, and software engineering. The application spaces for what we're interested in are smart buildings, smart mobility, smart environments, and smart networks. Today we're talking about, in particular, the smart buildings aspect of Enable and some of the research that's going on in this space within Enable partners, as well as in some of our industry partners. The source of the funding is matched funding to fully funded research projects between academia and industry. Enable also takes advantage of a number of real-world test beds, so we don't just do academic research, but we actually also try out our ideas in the real world. So we take advantage of test beds that are available through the Cork Smart Gateway in Cork, through Smart Dublin and Smart Docklands in Dublin, and also with Croke Park, which is one of the test beds. We also take advantage of other Ireland-wide infrastructure, for example, the Pervasive Nation IoT, National IoT Testbed. We also leverage our engagement in European collaborative projects. So some of the work that you will hear about today is also draws on European projects. So I've already mentioned the application domains. In terms of how we work or fund this industry and academia collaboration, there is a number of ways to do this. At a national level, we have funding through things like SFI industry fellowships. We have EI innovation partnerships, or the Irish Research Council partnerships. Through Enable, it's a partnership between academics in the SFI research centers that are hosting Enable and industry. So this ranges from 50-50 funding in a collaboration where we work quite closely with industry to 100% funding, which would be contract research. So if you look at how this would work also from an IP perspective, so the cost share, if it's 50-50, the IP is based on the national IP protocol, is hosted within the university partners or the academic partners, with industry having typically exclusive, or depending on the license, sometimes might opt for non-exclusive access, up to 100%, where industry basically take advantage of our expertise to solve a problem that is 100% owned by industry. Usually the way we work this, and today is kind of in a way part of this process, is to tell you about what's going on, is usually the industry engagement that we go through is an initial meeting where we talk about particular topics. So today, for example, it's us talking about some of the topics that we're working on, to inform you. If there is interest among the participants, for example, then we can organize a workshop where we scope the project and so on, and lead this towards a collaborative research agreement, and then a project start where the partnership focuses on particular problems of interest to the partnership to find solutions to this. In terms of our ongoing industry engagement, we have quite a number of partners already with whom we're working, such as Huawei, Intel, the Dublin Airport Authority, Netgear, for example. We have a partnership with the councils, so Cork County Council, Cork City Council, for example, and also companies like Johnson Controls, AROP, and then other public organizations like Transport Infrastructure Ireland, for example. This is a quick example of some of the projects that are ongoing, or might have or have already taken place. Some are finished. So, for example, projects looking at dynamic management of serverless functions. This is a project with Huawei, for example. Mobility on demand and paratransit. For example, a project with Route Match. Looking at digital strategy around smart buildings and mobility with Cork City and Cork County around the Cork Smart Gateway, for example, or looking at topics around waste management and resident behavior, for example. This is with Access Green, which is a startup in Dublin. So some of the larger initiatives we're working on are around the smart docklands with around Dublin Smart City Testbed, where we're looking at use cases around people movement, congestion management, and flood monitoring. And with Cork City and Cork County Council around the Cork Smart Gateway, for example, where we're looking at digital strategies around in the Cork space, and here it's smart buildings and mobility in particular. So this is some example of the academic experts involved, and so some of us are on the call here today, but there is quite a large ecosystem of academics from the three centres, which and the academics are based, for example, in Trinity, DCU, UCC, Cork Institute of Technology, and NUI Galway. So for today's session, which is more focused on smart and energy efficient buildings and communities, we've been working on this for well over 10 years now, 13, 14 years now, between academics in Cork, based in CIT and UCC, and industry in Ireland, but also through European projects. So it started in 2007 with initiatives such as the SFI-funded ITOBO strategic research cluster, which looked at digitization in buildings. This was kind of early work where we looked at how IoT sensing is applied in buildings, what we can do with the data to make buildings smarter and more energy efficient. It went through European projects, quite a sequence of European projects, such as SCUBA, Cooperate, GENIC, E2 District, Topaz, Möbius, and so on, which are projects that had strong participation from the research community in Cork, which looked at smart buildings, energy efficiency in buildings, in data centers, and also in urban neighborhoods. And currently, we are continuing this through both projects funded within the SFI centers, such as Connect and Insight, for example, but also predominantly through Enable, and a new initiative which has just started, which is a Center for Research Training in advanced networks of sustainable societies, and another research training center for new PhD students in AI, which involve UCC, CIT, Trinity, DCU, UL, and so on. So it's kind of leveraging the partnerships in many different ways now, not only to help industry solve problems, but also to provide new talent into the industrial environment. Okay, and just a quick, if you're interested in discussing any collaboration with us, I put in Emma's contact details here. Emma, who's the executive director of Enable, and she'll be very happy to discuss opportunities and bring in the right investigators for a particular problem. Okay, so just as a quick opening now, I'll hand over now to Dr. Alan McGibney from Cork Institute of Technology, who is going to present a joint work he is doing also with Dr. Susan Ray, who will be available for the presentations, for the question and answer session afterwards. So Alan is a group lead on IoT systems and user interaction at CIT and is based in the Nimbus Center. His research focus is in the area of distributed optimization, software architectures, IoT platforms, and the application of distributed ledger technology to trusted IoT ecosystems. Alan is really active in European research and is leading a number of participations in those projects. Okay, over to you, Alan.
Thanks for the introduction. Morning, everybody. So I'm just going to give 10 minutes, so I'll give a brief introduction of a couple of the projects that myself and my colleague, Dr. Susan Ray, are working on in the area of energy efficient buildings and communities. So maybe just to give a little bit of background for those who don't know the Nimbus Centre. So the Nimbus Research Centre is part of the Faculty of Engineering and Science at Cork Institute of Technology. So we're 100% self-funding, so we're very much a project-driven organisation, and we have approximately 40 staff, which range from researchers, engineers, software developers, admin staff, and of course students at PhD and master's level. So we work with a lot of companies through European projects, but also national programs such as Enable, and through our Technology Gateway Tech Centre as part of the Nimbus Centre also. In terms of the research activities, as Doc mentioned, over the last 10 years, we've been focusing a lot on the built environment, and some of the key enabling technologies that our focus has been on include digital platforms such as IoT platforms, hardware platforms, software, middlewares, anything that we can use to get data, visualize, distribute, and share and collaborate through. Obviously, digital transformation is happening, but it's quite complex for industry as well. So we provide support in terms of education and training, such as through community of practice, to advance digital skills. Having things connected is obviously fundamental to all digital platforms. So we do a lot of research and work in future networks, from wireless sensor networks all the way up to 5G. And obviously, cybersecurity is a very important topic in privacy at the moment. So we have a focus on all our systems around cybersecure technologies. So ultimately, what we're trying to do is make things connected, secure, and smart. And we've applied these across a number of different application domains, but specifically relevant to Enable. We've evolved, as Dirk mentioned, from looking at connecting buildings, making buildings smarter, toward a priority of how we manage energy to be more energy efficient. And then it's about scaling that up into communities, districts, and then see how these technologies can be applied in other industry sectors, such as smart manufacturing. We focus a little bit on energy and what the role of digitalization is in energy. So fundamentally, how we produce, consume, and manage energy has changed dramatically the last number of years. There's a convergence of energy technologies and digital technologies such as Internet of Things, big data, AI, and blockchain technology that's really enabling the sector to be more efficient in collecting data, managing the availability of data, facilitating collaboration and interaction, and ultimately to make processes more efficient to support the decarbonisation of the energy sector. So there's a couple of drivers really for the energy efficiency. So obviously we have to reduce our carbon emissions dramatically, and climate change, it's all over the media and the importance of it. So one of the focal points for us has been in buildings. So buildings produce a large amount of the energy usage across Europe, and our goal is to use digital technologies to be more productive with every unit of energy that we generate. So I'll give you an example of a couple of projects that we're working on in this area. So one of the projects is a European project called Topaz. It stands for Tools for Continuous Energy Performance Auditing. So within this project, what we looked at is what's the energy, why is there an energy performance gap? So what that means is you might design your building, or you might expect your building to operate at a certain energy rating. But ultimately, especially post-occupancy, lots of things influence that performance. And as a result, you don't achieve what you expect. So there's a major difference between what you plan to use and what you actually use. So this can be through faulty devices, poor commissioning, influence of occupants in the building, and other factors that might impact it. So what we try to do with Topaz is provide digital tools and methods to measure and analyze the real building energy performance. So what we want to move from is shift from doing an audit once a year and go to a continuous performance auditing approach that allows us then to ensure we don't miss any opportunities to save energy in our buildings. So a nice analogy that we use to describe this is we developed an IoT-based fitness tracker for your building. So what we did is it's similar to the enable loop. So it's like a cognitive loop where we ultimately make it easy to sense and understand how energy is being used in your building. From that, we can use that information to learn and provide optimization of the different processes within that building. We can act by implementing specific energy projects or activities, and we can optimize the utilization of our assets through the operational element of it. So specifically from Nimbus perspective, what we contributed in this project was across what we call the 3 Ps. So from a plan perspective, we developed an edge IoT hardware and platform, middleware platform that allows us to basically integrate heterogeneous building systems together and extract all that information out from the buildings. Using this information then, we were able to feed that into process optimization. So through modeling and model predictive control, we were able to automate and optimize the operation of certain assets in the building and eliminate wastage and maximize the potential for energy savings. And the third P is people. So the easiest solution to save energy is to switch everything off. But obviously this is not conducive to productivity for people who are working in the building. And obviously what we want to do ultimately is encourage responsible behavior for energy savings for the occupants. So we covered a core technology platform to extract the information, focused on modeling for energy prediction, control, and occupancy, so understanding the patterns of use in the building. And then we provided decision support on top of that, such as fault detection, diagnosis, being able to aggregate and generate key performance indicators for the end users. Air quality also played a big role in this. So in terms of the results, so we had 3 demonstration sites, and this one being Cork Institute of Technology, IBM's site in Dublin, and Bouygues Immobilia's headquarters in Paris. So we integrated 6 different buildings, over 7 building management systems, and a lot of data. And by using the Topaz platform, we were able to save energy in between 12 and 37%. So specifically in CIT, we were able to save 19% of energy through the use of this platform. We also were able to minimize the gap between the prediction models we had for the energy use and the actual energy use, which is a lot more difficult, but we were able to achieve between 11 and 27% across all the different sites. So a couple of other projects that I'd like to talk about briefly today they're funded from the SAI. So blockchain is obviously receiving a lot of attention in the research community and in industry, and it's seen as a key enabler for the energy transition. And the reason for this is because the grid is becoming much more decentralized, and this maps quite well to a blockchain, or more specifically distributed ledger technology. So it's a distributed system where you can have an immutable record of all transactions across different interactions between peers. So we use smart blocks really to give us kind of a platform to experiment with distributed ledger technology and its application in the smart building space. So what we did in this project is we integrated a smart meter with blockchain connectivity. And then, so that's ensuring that we have reliable data. So if we consider the rollout of smart meters at the moment, you can use blockchain to ensure that you can maintain ownership, privacy of your data and share it then between the relevant stakeholders that need it. And on top of that, we try to automate certain digital processes. So for example, energy performance contracts using smart contracts from the distributed ledgers, which is basically a small snippet of logic or business logic that is connected and executes automatically when certain conditions are met. So for example, if I agree to save you a certain amount of energy, once that energy is saved, you don't have to rely on trust in me that I've done that energy savings. The data tells you that you have your immutable record that the data says you've saved this much energy, and as a result, the contract executes. So we've extended that then obviously towards the smart energy communities, because this is a key factor of the energy transition as well. And what we want to do is, so we have the building level. So now let's see if we can use distributed ledger technology to support or create like a trusted layer between the different peers and stakeholders that participate in the smart energy community. So you have different actors that may be producing energy, just consuming, want to actively participate in integrating with the smart grid. You might have auditing, all these different elements combined together. So what we looked at is how, or what we're looking at is how we can use distributed ledger technology to provide a kind of trusted middleware between all these entities. It's quite an interesting project. So just maybe to summarize the research priorities that we're focused on in this area at the moment, if we're to have all these technologies, they need to be quite easy and low barrier to entry in terms of easy to deploy for consumers. So that's quite an important thing for any digital technologies. There's a need to have a decentralized energy system, and that requires a reliable digital infrastructure as a backbone to it. We want to be able to facilitate data sharing between the different energy stakeholders, and trust plays a big role in this for us. And using these different digital technologies, we want to enable new markets to allow consumers to become active participants in the network. So there's another initiative as well in the EU called the Smart Readiness Indicator. So it's to allow us to understand how ready are our buildings and people to respond to the distributed grid or the future smart grid. So this is another interesting research area that we're engaged with. So we're looking at from the technology perspective, the engagement perspective, the people involved, and also cybersecurity plays a big role in that. So what's next for us? From my perspective, one of the biggest drivers of research and innovation in the next couple of years is going to be the European Green Deal. And within this, if you look at the roadmap, there's quite an emphasis on the digital technologies and the use of interoperable data and data-driven processes. So for us, Enable is a perfect tool to allow us to engage with industry and other academics to kind of start at a national level to develop these ideas and these projects out, and then allow us to kind of contribute at a European level and access some of the funding from the Horizon Europe and the Digital Europe that's coming out. So thanks very much for your attention. I think I stay within the time. My contact information here, or myself or Susan, can contact, are happy to answer any questions at the end of the sessions.
Our next speaker is Diarmaid McSweeney from Analog Devices. Diarmaid currently leads the Intelligent Buildings business unit in Analog Devices here in Ireland. Diarmaid and his team play an important role in realizing the company's vision for intelligent buildings, infrastructure, environments. He started his career as a mobile handset design engineer in Freescale, and then moved into the startup world, where he developed solutions in the area of cellular connectivity for emerging standards. Diarmaid joined Analog and has held a number of roles in technology development and business leadership. He's a graduate of UCC with an MNC in electronic engineering. Over to you, Diarmaid.
Good morning, everyone. Glad to be here this morning. So my name is Diarmaid McSweeney, and I'm from Analog Devices. So first of all, just to introduce who Analog Devices are. So we're a technology company who've been in Ireland since the 1970s. The company has been in existence with over 50 years. If you used a mobile phone today, your data has passed through our products. If you have traveled by car, whether it's airbags or electric vehicles with battery management, you've used our technology. So we're pervasive in industry across many application spaces, creating the core technology that helps enable what we have around us today. So what we do, so we focus on interpreting the world around us. So we create the technology that can translate the real world phenomena into insights. So that's the ability to sense what's happening, to measure that, to maybe make decisions at the edge on what's happening. So we create the data that's often fed back into the bigger systems to make the analytics and to make I suppose, to generate those real world insights about what's happening. So in terms of, just to kind of set the scene, so we're, I suppose there's three big mega trends that I look at, and that's the trend around urbanization, the move of people into cities, and that's growing from around 55% of the population today to what's predicted to be 65%. We have the trend on climate change and sustainability, and we can look at the energy consumed in buildings at 40% approximately of the total energy consumed globally. And if you start to break that down, you look at what's consumed in the various applications or utilities, whether it's HVAC, lighting, or just having space available for people. It's a significant percentage of the overall global energy consumption, and there's clear momentum to reduce that. And then we have regulations and standards. So, whether it's energy efficiency or whether it's new regulations around fire detection, smoke detection, or as there's moves globally to more non-pollutant refrigerant and HVAC, again, more gas detection. So these trends are driving technology innovation that we're involved in. Now, there's one big disruptor that I don't have up here, and that's what's happened in the last 5 months. So particularly in the intelligent building market, the impact of COVID and how that's changing the environment is a very, very real topic. So there's many things I think I keep going. There we go. So there's many areas in the intelligent building space that I could talk about. In the space of 10 minutes, I'm going to bound it to what's within the four walls. I'm not going to talk about energy. I'm not going to talk about energy storage and all of that, right? So just keeping within the four walls of the building today, the use cases that we're involved in stretch from the sensing of what's happening, whether it's safety, access control, HVAC, what's happening with our space, the climate or the environment, and then the ability to take all of this information and to automate the decisions that need to be made to make the building more efficient, more productive, and to make it a better space for people to work in. So having that better environment for people is one of the biggest value adders for companies who either operate or own these facilities. So, just some themes that to draw out that I see happening in the world today. So, we see this change in intelligent buildings. So they're moving, or they have moved from a place where people just gather, and I focus primarily on the industrial or the retail or the commercial building, now to being buildings where they're more, I think, sensitive to people's needs. So a space where that understands the occupant's needs, a space where it can predict those occupants' needs in advance to better optimize the efficiency, the utilization, and the overall productivity of that building. I like to think of buildings, being user-centric. So as you walk into a facility, that it becomes that we're using technology to make it easier for people to enter, with access control technologies moving from smart cards to fingerprint and now into touchless technologies to gain secure access to a space. We can look at the utilization of space and the technologies that we have to understand what's happening in the space. So Alan mentioned some of those technologies earlier. We create the underlying technology that enables those types of use cases to understand where people are within a building, what they're doing within that building. So then you can start to optimize the use of the building, maybe enable particular rooms, or enable, turn off the lighting on particular floors, or optimize services such as cleaning routines. There's a lot of value-added services you can now provide when you understand how your facility is being used. Then you start to look into the sensing of buildings. So if you understand the environment of the building, whether it's the air quality, the lighting levels, all of those environmental factors play an important role in making it a more productive space. So if you're looking at let's say the carbon dioxide concentration in the meeting room, and you have 10, 12 people in that meeting room, you want to optimize that to make it a more, let's say, more productive space by increasing the oxygen level in that room. You have to be able to digitally connect to all of these measurements. So being able to trust the data that you're collecting is imperative. So cybersecurity is a must-have. It's a baseline for any of these technologies. So whenever we look at new technologies, we start at that point. We look at, there's multiple ways of connecting to sensors with both wired and wireless technology. In the wired space, we see standards emerging, new standards such as the IEEE 802.3 standard that allows Ethernet connectivity over twisted pair wire. So that is a new standard that was ratified in 2019 and has the potential to disrupt in this intelligent building space by now, in the retrofit of, let's say, legacy buildings, where you want to connect securely over existing copper infrastructure within the building. We see this, standards are starting to emerge, which is important because that drives interoperability and that gives scaling in this type of application. Also in the wireless space, whether it's through cellular or low power networks, we see cellular with 5G moving into licensed spectrum for private use within buildings. So we see these trends happening that will enable the connectivity to sensing and to measurement and to actuation to make all of this work. And the final trends that I think is important to talk about is around the standards around safety. So buildings are changing, the materials are changing, we want to create safe environments for people. And I've picked one example. So we're involved in all types of sensing, smoke detection, gas detection, air quality indication, all of these measurements. But one of those that I've drawn out here is smoke detection. So when we talk about what's changing in the standards world, the regulations and the standards around smoke detection are evolving. One of the trends, if you look over historical data, is that in fatalities in fires, many of those were attributed to people having taken out the batteries in their smoke detectors due to false alarms. So by being better able to measure those smoke events and distinguish even different smoke types, you can create a more accurate and reliable smoke detector. So new standards are emerging there that will be ratified in the US in 2021. And we're part of I suppose we've created the technology that enable companies to be able to measure what's happening in the world around them, for example, here with smoke detection. So that's a summary, a very, very brief summary of some of what analog devices are doing in the intelligent building space. There's much, much more we could get into, but I just wanted to give you a small taste today.
And I will talk about our work in IoT and AI and smart buildings. So as Emma said earlier, I'm a professor in the School of Computer Science and Information Technology at UCC. I was formerly the head of the Nimbus Research Center, so some of the work will resonate a little bit with that. And so Alan and Susan mentioned some of it. So I'll touch upon some aspects that I was involved in previously when in Nimbus. Ken is also a professor in the School of Computer Science and IT in UCC. He's also the deputy director of the Insight Center for Data Analytics at UCC, and has been involved in a broad range of projects applying AI and machine learning to make our world smarter and a better place. So we as people spend most of our time in buildings or in our homes, and more recently we've been very much confined to our homes. So we want those buildings and homes to be both comfortable, supportive, efficient, and safe places. And as Diarmaid said earlier, our buildings also consume a lot of energy. So we don't only want them to be safe places, but efficient. So we want to reduce the carbon footprint. So the question is, how can we do this? And so there are different ways of doing this. One of them is deploying new IoT sensor technology to make buildings, to monitor and support building energy efficiency. So some of the work that we have done in the past involves, and this work was done through a number of projects when I was at CIT. So work that involved collaboration with Susan and Alan, involved deploying IoT sensor networks, for example, in data centers. This was through a European project where we augmented a small data center with sensors, monitored energy efficiency, or monitored energy consumption, humidity, airflow in this, with a view towards making it more energy efficient. And a big problem with data centers, in particular with smaller data centers and server rooms in enterprise environments, is that they're often cooled too much because there's not enough intelligence on how they operate, how far they are away from a critical temperature point, for example, and so on, how there's not enough mechanisms to alert operators, for example, and so on. So there's a lot of opportunity for energy savings in this space. Another project involved work in the Cork School of Music, where we worked with the operator of the Cork School of Music. It's a public-private partnership. And what we did was we enhanced the monitoring of an air handling unit. Air handling units are very typical for big environments, but often they consume way more energy than needed, because often not enough insight into the operation is available, because traditionally they don't have enough sensor augmentation. So this project focused on retrofitting sensors to air handling units, opening up the building management system to get more data out, and then look at techniques for fault detection and analytics in order to detect when energy consumption was too high, when the optimum operational points weren't met in the air handling unit, and so on. And so during the project, we found out that there were a number of problems with some of the air handling units, and we were able to advise the building operator how to fix them, for example. Another project involved deployment of a building energy testbed in the Nimbus Center, and Alan mentioned already some of this, which has been used in a number of European projects. So these are examples of work that has been carried out in the past to demonstrate how additional retrofitting, in particular of wireless sensor technology, can help get more insight into how buildings operate and help to make them more energy efficient. If we move from buildings to urban neighborhoods, we were involved in a European project in collaboration with the United Technology Research Center, Intel, Bouygues in France, and so on, where we looked at the at ways of linking buildings in urban neighborhoods with a view towards enhancing the overall energy efficiency of those neighborhoods through potentials like trading energy between buildings, for example, exchanging information, data between buildings, and so on. And so some of these, some of the buildings involved were in Cork, some of them were in France, and we applied an IoT platform that was developed in the Nimbus Center to it. And also we compared this and linked it to two other IoT platforms for building energy management, the Urban Power platform from Embix, which is a French startup joint venture between Alstom and Bouygues, and also an Intel-based IoT platform. And we demonstrated how trading of energy and balancing energy between buildings can help make buildings more energy efficient. Out of this came a book on energy positive neighborhoods and smart energy districts, the first book of its nature, published by Academic Press. So I mentioned that this kind of deploying IoT technology in buildings and so on can help with this, but also what we're seeing is that there are so many different types of these building monitoring technologies. So if we look at it, there are technologies like Zigbee, Z-Wave, for example, and so on, threads that are used in home environments. There are professional building management technologies like BACnet, KNX, Lawnworks, and so on that are used in corporate build or commercial buildings, for example. And also, as Diarmaid mentioned, there's a lot of emerging cellular technologies now, machine-to-machine communication technologies. So we have a complete zoo of those technologies now that all support making our buildings and homes smarter. But the problem is this fragmentation leads to a situation where data cannot be effectively shared between those, and that leads to inefficiencies and so on. So work we did with an industry partner through the Connect Center, for example, was looking at interoperability in this. How can we come to a situation where we can have a building or home where multiple of these sort of different technologies are integrated and they can cooperate with each other. So for example, in a home, you might buy a Zigbee light switch, for example, but you have a Z-Wave or a Bluetooth light, and how can you use the Zigbee switch, for example, to turn on and off the light? So we looked at approaches to deal with this, and there is a number of publications that have come out of it. Okay, I'll hand over to Ken now to talk about how, once we have data available from buildings and so on, what can we do with machine learning and AI to enhance those?
Okay, thanks, Dirk. So I'm just going to pick up on a point Diarmaid mentioned in his talk, that one of the aims of the analog work is to make buildings sensitive to people's needs. So that's what we're trying to do here, is use the AI systems to exploit all of the data that Dirk and Alan have been talking about that's provided by the IoT systems to make the buildings more responsive to what people actually want and how people are using it. So I'm going to look at two different bits of work. The first one is completed work from a few years ago, and then the second one is work in progress. So the first thing we're looking at here is measuring how occupants actually respond to the thermal environment in the building. So there's lots of industry standards out there, and the main one is based on what's called PMV, predicted mean vote. that suggests or gives a predicted temperature setting for any given humidity condition that says the majority of people will be satisfied with this. So what we did is we used a range of sensors that were built by colleagues in Tyndall, which we placed on individual desks throughout a number of labs in buildings in Cork and Galway, including the Nimbus building that Alan mentioned earlier. So these were measuring temperature, humidity, CO2, radiant heat, light, and also occupancy at the desk. Okay, so we were then prompting users on a desktop app and a smartphone app to tell us how they actually felt about the environment. So we weren't asking them for their opinion on temperature or on humidity, we just said, how are you feeling? Okay, and this would pop up throughout the day. They would give us a response, which we can then tie back to the detailed sensor data from their desks and from their environment. Okay, we're then able to exploit active learning. So once we start to build up a picture of how the user responds, we then only prompt the user when we're in situations where we're not quite sure what they believe or what they prefer. So we cut down the interaction. So the first thing to note is the graph in the middle, and this is just showing for one particular humidity setting in a building. It's showing how the people actually tell us they're feeling compared to the industry standard. So the black line is the predicted mean vote standard, and you'll see there's a point where the black line crosses the 0 in the middle, and that's the standard says this is the ideal temperature for the building. The dotted line you'll see is actually the mean response of the users. So the black line is predicted mean vote, the dotted line is the actual mean vote, and this is over 60 to 70 users varied through those buildings. So you'll see that it's reasonably similar out at the extremes, okay, whether it's too hot or too cold, but in the middle, the industry standard is not getting it right. Okay, so for this group of users, there was a clear preference for over 1 degree cooler than the industry standard was giving them. Okay, so we believe this is actually quite important, and that we should be using the data that's coming from the sensors, feeding back to the control systems to control the thermal environment to respond to the actual users who are in the actual rooms, rather than the long-term studies that have been in the literature for a number of years. Over on the right, you'll see, sorry, if we can go back to the previous slide, Dirk, thanks. Over on the right, you'll see something else. This is actually based on a large open plan lab, and what we're showing here is the response of people at individual desks. So the two squares there represent the floor plan of the open plan room. You'll see there's a variety of comfort. There's one person there in red that indicates they are persistently or consistently saying the room is too hot for them. So one individual is consistently not happy, whereas others are reasonably content with the environment. The one at the bottom is showing the variance, and it's showing whether or not people are saying the same thing or whether their opinions change over time. And you'll see there's a strip down the left-hand side here where there appears to be a higher variance, so that people are changing their opinions. Sometimes they're satisfied, sometimes they're not. It turns out this is a large open plan lab, and this left-hand side is floor-to-ceiling windows in a southwest facing direction, whereas on the right-hand side, it's an internal wall. So there's a clear temperature or thermal gradient in the room, where the people at the window are getting unwanted effects from the radiant heat coming in, and the building is not able to respond in time to satisfy their preferences. So the idea of this overall work was to feed this back into the control systems, and then to try to adjust the conditions in the room to respond to the individual users' requests. Okay, thanks, Dirk. We can do the next slide, please. Thanks. Okay, so this next one is work that's in progress, and this is a large European project where we're looking at it says secure, connected, trustable things. We're focusing on secure facilities management, and the idea here is we're trying to do dynamic control of the access control system in order to make new temporary secure zones based on the presence of assets or hazards or VIPs or intruders or people who need to be protected and isolated. So we're using IoT data to track people as they move through the space. We're using AI to predict their movement paths and the speed at which they're going to move along these paths. And then based on various policies imposed by the building manager, we then solve a combinatorial problem using our AI-based methods to propose new security configurations, which can then be actuated automatically. So there's just some screenshots there. The one on the bottom left is from work in a university building in Gdansk, where we're showing when a particular asset we want to protect is moved through the corridor and moves into one room. At the point it moves into the one room, we can then open the doors to other rooms into the corridor to say this is now free space and there is no need to protect that zone. The one in the middle is actually an outdoor demo. This is because we've been excluded from the building since the beginning of March, so we can't complete our demo in the building. This is just showing what happens as we're giving people routing guidance through a space, and then a protected asset moves into a particular zone. And so as we track the movement of the protected asset, the guidance we give to individual changes in real time, and they're directed away from the danger. Then the thing in the top right is just a mock-up, and this is really work in progress that we're doing right now. This is an example of a floor plan. So from the floor plan, from the building information model, we're then able to extract a topology graph, okay, showing all the various doors that can be locked and all the different locations. Could you advance the slide a little, please, Dirk? Just one press, thanks. Okay. So we extract this topology graph that then gives the connectivity results. All of the doors are controllable. We then take the building manager's policies and compute the solution that maximizes whatever the objective values were for the building manager. Could you advance again, Dirk? Thanks. So based on the presence of various people, what they've asked to do, what connections they need. For example, they have to have access to a fire escape. Particular visitors may be given access to printing facilities or toilets. We can then create dynamic zones, okay, around those particular people to achieve the objectives. Okay, so that's where I'll leave it. As I say, this is ongoing work, and we're in the final stages of completing that project, and we would be happy to talk to anyone on particular applications of this.
Okay, thank you very much, Ken. Here is Brian Cassidy from Cork City Council. Brian is a senior executive engineer in Cork City Council's Housing Maintenance Department, and he's currently engaged in a number of European projects and the department's deep energy efficiency retrofit program. So he's going to talk about that, how social housing is affected by the deep retrofit program. Over to you, Brian.
Thank you, Dirk. Good morning, all. I'll get straight into it. Social housing deep energy efficiency program. I'll just tell you a little bit about Cork City Council first. So for those of you who don't know, it's the second largest city in the Republic of Ireland, where the council serves a population of 210,000. It's democratically accountable, and its overall aim is to make Cork an attractive place to live, to work and to invest in. There's a number of service areas provided for the administrative area. These include housing, environment, water and amenity, strategic economic development and planning, international relations and tourism, roads and transportation, community culture and placemaking, environment and infrastructure. I worked, as Dirk said, in the Housing Maintenance Department. So the council owns and maintains 10,000 social houses within the city. From an energy efficiency perspective, over 50%, and even construction detail, over 50% of these are of single wall construction. The oldest properties, or the first ones built, social housing in Cork City, go back to 1886, and you'd see them there in Madden's buildings. What do we face in our current working environment? We face increased regulation, like everybody else. Landlords' responsibilities are increasing, including social housing landlords. And we work to the Residential Tenancies Act, and we will be reporting to the Residential Tenancies Board. We also must work with the building regulations, of which there are, my memory is certainly correct, 13 parts at the moment. our industry, since the first houses were built in 1886, the complexity of housing stock has changed considerably. So first to be put into the house was toilets. First they were outdoor, or retrofitted into the housing stock was toilets. First they were outdoor, then they became indoor. Running water was provided, electricity is provided, heating was provided, or is provided, and energy has now become, or energy efficiency has now become something that we must take care of. So the result of all this is that our maintenance costs are going up. We also faced an aging tenant age profile that is increasing as our tenants are living longer. Smaller family units means that there is greater demand within the existing population for social housing units. And going back to the energy, there's a need to meet the NZEB requirements of the building regulations. So, social housing projects in Cork. So starting around 2004, or the early 2000s, we did central heating system installations, nearly all gas-fired, gas boiler fired, into 4,000 units in the city, starting in 2004. That project went on to about 2008. Why didn't we do 10,000? Well, at the time we would have had about 8,000 houses, and a lot of people had installed their own systems or they didn't want gas. So we got through about 50%. We also started a Windows upgrade program around 2005, and about 5,000 houses had Windows installed as a result of that program. Then in 2010, we were asked to do a demonstration project by the Department of the Environment to see could deep energy efficiency retrofitting be done with the tenant in situ. This was a big concern if we were going down the energy efficiency route and improving the fabric of the building, because as a housing authority and a large landlord, we couldn't afford removing people from housing and decanting to somewhere else. It's a very costly exercise. As anybody who has exited their own home for the purposes of doing a deep energy efficiency program will tell you. And that, you can see it there. 2010, we did 32 apartments in a place called Sunview. One little addition we did there, not related to energy, or it is partly related to energy efficiency, is we put in a passive rainwater harvesting system in there, which is working to this day. 2014, in 2013, we commenced a shallow retrofit program, which we upgraded the attic and cavity wall insulation in our social housing stock, and that covered about 6,500 of what was then 9,000 houses. So why didn't it go further? Well, 10% of people weren't home, or when we called, and didn't seem to be around whenever we called. Another 10% just didn't want it and said no, not for them. They weren't interested, and we had other stragglers as well. In 2014, we commenced an energy efficiency improvement program to vacant houses. So when a house became vacant, we did certain measures. Like a lot of the vacant houses actually ended up doing the attic and cavity wall insulation program, because the elderly tenants either didn't want the program or they were in hospital and weren't available to allow entry. So we've about 1,200 houses completed in that program to date. That will include boiler efficiency upgrades as well. We also, starting in 2015, with a local community-based organisation, participated in a number of SEAI Better Energy Community schemes. You can see one of them there, up there on the top right, where we would have had a certain level of funding from ourselves and from the department, and we would pool that with the SEAI funding through the Better Energy Community scheme, and do energy efficiency upgrades to the house. And the results there have been quite good. We've been getting up into the B2, B1 category there in quite a lot of those houses. And finally, in 2018, we started the apartment deep retrofit program, which is to date has been completed in 129 apartments. Just to give you an idea of the difference in costings, the total value of the fabric upgrade phase 1 program was about 13 million. The energy deep retrofit program on 129 apartment units to date is coming in at 6.5 million. So there's quite a you know, your investment goes up the deeper you go with your energy efficiency retrofitting. So we're also involved in a number of EU projects because we have a lot of advantages to gain from going down the deep energy efficiency route. Not only do you increase the efficiency of the building, but you are providing a better home and a better quality of life for the occupants. Particularly the older housing stock can be prone to levels of dampness that are uncomfortable. So the first one on the left there, Interreg North Sea region Indozero project. I'm an advisor on that project. Its aim is to industrialize the whole process of deep energy efficiency retrofitting, reduce costs by up to 50%, and do the process in one day. That's proving difficult on it. So that's the Interoperable project. The Interreg Northwest Europe Red Wolf programme, we're engaged in that with Carberry Housing Association based in West Cork, and with the Institute of Technology in Sligo. They have a contract research unit there. Its aim is to look at is to look at availing of off-peak loads to charge batteries in homes, and to see what gains in efficiency can be gained, or reduced carbon can be obtained by charging batteries offload in the home and then using it to provide heat to the home and to provide electricity to the home. Another one we've just started there is Mini Store, which is a similar type of project, but using different technologies to achieve a similar type of aim. We're putting that into one home here in Cork. Red Wolf is going into 10 homes around the city. Over on the right-hand side, we are involved in the two Interreg Europe programs. One is in Intensify, which is really it's a community engagement project, and we have found through our deep energy efficiency program that community engagement is key. You must bring the community with you when you are carrying out these projects, because they're the people whose lives are greatly affected. So we're learning a lot from our European partners on that project. On the Empower project, it's run by the Southern Assembly of the Irish partner. We're their main stakeholder. It's looking at the benefits that monitoring and measuring energy consumption in the home can do to reduce carbon production and reduce energy costs for the homeowner. So we have selected 8 homes there for that project. The equipment was to be installed in March, but coronavirus has put paid to that. So we're hoping to start up in July, August, and the contract has been placed. The contractor's on board, so it's just a matter of doing the installation. On the Build Upon 2 project, this is the Irish Green Building Council, are the Irish lead partner here. We are a follower city. Dublin City is a leading city. We're a follower city. Again, learning what other European cities are doing in terms of improving the energy efficiency of their housing stock. And also there will be a one-stop shop provided with that project as well. Finally, the Horizon 2020 Upstairs project. We're engaged with that annual mini store with Tyndall and the International Energy Research Centre. So it's starting in September, and its focus too is the one-stop shop. I'll just go back there. The group in the middle are the people who provide the money. Cork City Council, the Department of Housing, Planning and Local Government, and the Southern Regional Assembly through their Regional Operation Programme 2014 to 2020. So achieving NZEB, from a landlord's point of view, what are the challenges? Well, a lot of terms are bandied about as to which way is the best way to go, including should we regenerate, should we refurbish, or should we retrofit? From a housing maintenance department point of view, to control the costs and to focus on what the project is trying to do, we're focused primarily on the latter, retrofit for energy efficiency, and keep the others separate. Otherwise, costs start creeping up from around 60 to 80,000 to 100 plus, and there aren't too many people willing to provide money for that, and the payback period is just prohibitive. Other questions we face: should we be doing an incremental versus a deep retrofit? Some people think deep retrofit is the only way to go and achieve your NZEB standard in the first go. Others have the view that, well, you know, lower the cost per home and spread the money a little further. And you saw that with the shallow upgrade of all houses and the deep retrofit of 129 apartments. That's, you know, from a public service point of view, you can spread your money a lot further using the incremental approach and get to your NZEB over time on all units. Costs are difficult because you're trying to get funding from various sources, whether it's through the EU, whether it's through the ERDF funding, SEAI, Department of Housing, and really it can get quite complicated, and it's something that we should be looked at with a view to streamlining the cost model, particularly for the social housing landlords. A common crib with this from all landlords is that the landlord pays the money to upgrade the house, and it's the tenants that's saving the money on the energy bill. And there is a barrier to incentivizing the landlord in that people think, oh yeah, if you improve the energy efficiency of the home, you save on the energy bill, and the landlord says, well, I don't pay the energy bill. So there's needs to be something there to split the incentive between the tenant and the landlord. Another issue we faced, and we discovered this when we were doing Sunview, was floor insulation is not possible in an occupied house. It's too intrusive and too obstructive for the tenant, and that raises question about radon. And you know, is there a risk of increased radon in the home because you have reduced the air circulation? And that leads to the next one, then, ventilation concerns. Are we getting it right? Are we removing mold or promoting mold? And we've seen both instances in our own work. In the general industry, in general contracting, building is getting much more complex. Building is demanding more and more knowledge by the operators of the construction of a building, and that leads to the need for skill sets. And are those skill sets there, and is industry in a position to supply it? Maybe post-COVID-19, we'll end up with a surplus, and we will get those skill sets into the industry. There's also verification costs and performance measurement costs, particularly if you go down the incremental route, where you've got to produce, demonstrate that you've made the actual improvement in theory to the building energy rating. This all costs money, and as a landlord, you're kind of looking and saying, well, where's the benefit? Where's the long-term benefit of all this verification? Tenant engagement, I mentioned previously, that's very important in order to gain access, and to particularly tenants, many of them working part-time jobs, many of them working long hours, odd hours, and contractors and the tenants need flexibility in terms of gaining access. So for the contractor, it doesn't necessarily mean 9 to 5. It can mean odd hours because the tenant is working odd hours. Mixed estates, public and private estates, can be a problem. We find in our own work, we've no problem, we can get money for the public side of it, but then on the private household side, there mightn't be money provided, and yet we have a responsibility as a landlord for the complex as a whole. So you get the idea that the public occupier or social occupier is getting a B2 house, and you're providing maybe a C1 to the private householder in the same complex. So that can be a source of division. So that's it. I'll hand back to Dirk, and thank you very much for listening.
Final speaker is Kieran Gulsenin from Dogpatch Lab. Kieran is a civil engineer and currently the general manager of Dogpatch Labs in Dublin, which is Ireland's #1 startup hub. And he there leads the urban innovation IoT strategy. Prior to Dogpatch Labs, Kieran ran his own technology startup for 6 years as CEO and founder of Building I, which became an award-winning company visualizing and analyzing building permit and planning data. And the company still runs today with work with cities such as San Francisco, Palo Alto, Cupertino, and Pittsburgh. So Kieran, I'll hand over to you, and
Great, thank you, Dirk. Welcome everyone. I'll probably break this into two parts. One would be just explaining what Dogpatch does as a startup hub, and then what kind of smart city, smart building technologies we're testing and deploying in Dogpatch. So Dogpatch is in the CHQ building in Dublin, a 200-year-old, 150,000 square foot unique protected structure. This photograph here is just our vaults meeting room. So we're based over 3 levels, our vaults area, our ground floor, and then our new mezzanine level. And what we're really doing is, let me just get into this. Our mission really is to accelerate the development of the Ireland's ecosystem. So what we have in Dogpatch is a range of companies. It could be very early stage. It could be 1 or 2 people just working on the technology idea, testing if they actually have a business, up to companies that have 50 to 60 people have raised 100 million. So it's that in between all of those, from our startups, the very early ones would be using hot desking, and this would be typically in the urban garden, the first floor level, which you see there. And then we have dedicated desks on the ground floor for companies from, say, 4 to 6, and then we have some private offices. So really what we do then is we run a bunch of different events. This one, for example, is a mentoring startup gathering from people all over the country who come to Dogpatch at least once a month for First Fridays to actually get mentoring and meet with other startups and network. So let me just see. So we don't just have startups, we actually work with our corporate partners. So we've got corporate partners like Google for Startups, Ulster Bank, who have their innovation team, ESB, who have their innovation team in there. We have Alltech, who we've worked with on agricultural tech, where we've done accelerators, we run incubators. So we'll work with teams that are trying to build out ideas within their own company, and then actually companies that are looking to see what technologies are out there in their domain, whether it's agricultural tech, fintech, construction tech. Other partners that we've worked with are currently working with are Unilever, Hanover Re on reinsurance, and most recently ARM. So I'm going to just show you some deployment that we've done with ARM just later on. We're actually really uniquely positioned in the heart of the Docklands. So we've got all of these technology companies right beside us. So we've got the likes of Twitter, Intercom, LinkedIn. So it's a really vibrant ecosystem where we're based. Just by the numbers, just to give you an idea, we have about 80 companies in Dogpatch, 480 members. Our partners, our corporate partners that we discussed, we've got 8 of those, and quite a diverse group, people from 27 different nationalities. So yeah, really unique, great ecosystem in Dogpatch. Here's just some of our members so you can get a sense of who's in there. Again, like Food Cloud, Colour Dojo, Pivotal, ChangeX. So we've got social entrepreneurs, we've got for-profit, not-for-profit. It's just a mix. And it's really interesting when you do get that mix that you just don't stick to one vertical and everybody just works off each other, no matter what size they are. One company, for example, or Colour Dojo, if anybody hasn't heard of Colour Dojo, it was started by James Welton actually in Dogpatch. So amazing story of just teaching kids how to code. So now there's over 17,000 clubs worldwide and over 260,000 kids taught how to code. So people like myself and maybe many others like you will mentor over weekends just to help kids on Scratch. And because they're not getting this in their schools, so this is a great initiative. So we also have another company, very interesting, Caintus, set up by 2 brothers from Galway. So what they do is use computer vision and predictive imaging analysis to monitor the health and well-being of livestock. But we know them best as facial recognition for cows when we bring people in around the space. But really, really interesting company and doing super well. So they're a company that has started in Dogpatch quite small, and then we've seen how they've grown from a startup to a scale-up. We run a lot of events as well. So Dogpatch is an open door for any technology events. So we run about 10,000. We've had about 10,000 attendees per year. We've got the developer communities arranged, whether it's any type of coding, any meetup, we run it in there. We've run a bunch of hackathons, and I suppose any startup is measured by how many slices of pizza it actually consumes in a year. So we've calculated 8,000 with our data scientist. So onto our smart city side. So what we've done is actually we've partnered with Smart Dublin, which are part of Dublin City Council. And there's a guy in there called Jamie Cudden, who maybe you all know, but he's a great ambassador, and we've worked very well with Jamie over the past couple of years. This was a recent event that we ran with Jamie and Dr. David Ricketts from Harvard, where we ran a 5G accelerator. And what we do in that case is, the reason we're doing it in Dogpatch is because we're showcasing the technologies that we're testing and deploying in the building. And we have a bunch of different startups that are focused on smart cities, whether it's like Mobi, who do mobility, you got Waya, who do IoT, and they're just, you know, a selection of the startups that we have. So, I mean, our whole purpose here is to test and deploy technology. So a very kind of startup approach. Doesn't matter if it doesn't work, it's just get it in there. We don't need any permits because we're doing it indoors. And actually, we're just running on that an innovation masterclass next week with Dr. Ricketts. If anybody actually is interested, can talk to maybe to Emma or myself. So another, and I Dirk hit on this too, but if you look at where we are based right in the center of this smart district that has been established, about just over 2 square kilometers, where we can test and deploy smart city technologies. So we've really positioned ourselves to be that building within that district. And we're very lucky to have the owners of the CHQ building who are very interested in technology and saying, how do we actually test technologies and use the building to make it a smarter building? And not just on smart cities, but also smart tourism. We have Epic, who's based in the middle of CHQ as well. And another thing that we're working on, which I can share just a little bit later on, is we're also looking at a smart store. So we've got this smart district, and we've got this smart building within this district, and we're actually doing a smart retail store within the building. So some of the deployments, just to show what we've done already in Dogpatch and with our partners. So it's actually, it's great because we've got this unique kind of position where we've got government, startup hub, corporates, and universities all working together to test and deploy things. So the first thing we did was we tested, say, 5G with a company called Densair. And this is indoor 5G. So what they did was within this 150-meter long building, deployed 2 boxes. And that actually penetrated 5G inside the building. So we went from a 3 meg download upstairs to 98 meg. And what that does for our startups is that they're working on AR and VR technology, so we have 0 latency. And when we look at this store of the future, where we're putting a lot of technology into, we're bringing in 5G into that unit. That was just one. When we did our construction of the urban garden, so you'll see this urban garden space, it used to be open onto the mall, but actually we enclosed it in glass and then added an air handling unit. So during the construction process, we actually deployed Waya's IoT technology to understand, you know, what was the noise levels before we started, what was the noise levels during construction, what were the vibration levels. We looked at light levels. And then we also looked at when we deployed our air handling unit, we had different temperature levels within the actual space. So it was supposed to be uniform throughout, but we actually picked up in these graphs that at the very start, we had a consistent temperature, but at the end it was up and down. 2 of them should match. We actually showed this to the mechanical consultant, and they were able to tell that we hadn't throttled our air supply correctly. So that's an example of how we use the IoT to actually see a problem and then get it addressed. So, you know, the consultants couldn't really argue with the graph. So then when we actually look at this unique building, as I said, it's 200 years old. It's a cast iron structure. So each of these structures are unique. They're assembled, you know, were assembled on site, so they're not perfect symmetrically. So we were putting all of these likes of ducting through a center. And instead of having to measure every strut and every structure, we brought in Leica Geosystems. So they were actually able to survey the area in 2 hours to 3 mil accuracy and provide us with a model that we could actually load in our ducts to make sure they did fit or they didn't. And that would have probably taken us 3 weeks to do by hand with an architect. So that was something that we wanted to test with Leica, and they came in and then showed us what could be done. Other things that we've been doing is we have this hot desking space that I spoke to you about in our urban garden. So it's a bit of a mix of furniture here and there. There's no dedicated design, everything's flexible. So what we wanted to understand is, how is a space being used? What desks are popular? Which ones aren't? How do you get rid of the bad stuff, replace it with the really good stuff? And what we did was we did this test with ARM. So ARM, for example, were acquired by SoftBank back in 2016 for about 32 billion. They're known as a chip company, but they're into IoT. So we set them this challenge that we want to understand to 0.5 meter accuracy where people are sitting, how long they're there, what desks are being used, what's been underutilized, and how dynamic can the actual floor plan be. So we co-developed this solution. So this was the first iteration, and that's really what we were trying to do. So do it on the fly. It had to be GDPR compliant. So we're using edge processing. We're using camera technology. So there is no images stored, and the only output is coordinates. So no one has access to any of that data, only XY coordinates that are outputted to a dashboard. So this went from an early model into more of a dashboard now that we provide to or we will be providing to our members, so that you can actually go on here and see what the space is like before you even leave your home. And then understand when you walk in the door to Dogpatch, before you go to the first floor, is there space to go up there? So here's one example of what we're working on at the moment. So we have a physical distancing tool that with our sensors, we can tell where people are within 2 meters of each other. And we've just been testing this to see how it works. Now, we can't go policing everybody to say, look at your 2 meters, because we just don't have the resources to do that. But if we can see that there's a consistent level of this happening, we can put up signage, or we can start changing things and look then to measure that. So here's what we've done. We've put our floor plan as a baseline, and then we've done a heat map over that. But then to actually get in and look at how the desks are being utilized, we have another layer that actually gives us, the green shows us where people are sitting, and the red shows us which tables or seats are unoccupied. Now, I suppose, why are we doing this? Well, I suppose we're trying to understand how is our space being used and what things do we need to change. We actually identified that there was areas over here that people really liked. So this data allowed us to go and talk to these people. And then what we found out was not that the seating arrangement or the tables were great, but actually they loved the seats. So we now need to buy more of those types of seats, because that's why people are sitting there. And they were also close to the Skype booths where people go to make some phone calls. So by seeing all of this data, we were able to go and validate a lot of it by just talking to the people that we knew actually sat there. And then when we actually take this data and we put into a dashboard that we've done, we can then understand what tables are the most popular. So we've identified them with tags, which are the least popular. And then we'll go to change the stuff that isn't working really well with the stuff that we find does work really well. What are the peak occupancies? This is just a mock-up of the data that we've been taking in. But it's been really insightful for us to actually have this data at our fingertips now, and then to scale this out into the actual overall building. So I can actually tell from my home how the space is occupied in real time. Next projects that we're actually looking to test and deploy, I'll say we are just finishing our retail store. So this is our smart retail store that we're doing with our partners. So this store is just about testing retail technology and understanding what retail technology is out there. And this, again, like the urban garden, is a place to bring in the latest technology, test, deploy it. We're also actually bringing in startups that can't get into retail stores, but have an innovative, say, hardware application or product that they want to test. And we're opening this up to startups to bring their new products, put them onto the tables. Then we'll use the likes of the ARM technology to understand dwell time, people movement, what products worked beside another product, how long were people staying at a certain product. And we're then going to feed this data back to the startups and say the corporates that we've been working with to say, this is how a retail store works. We'll analyze this as a baseline to understand how it works over 2 weeks. And then we can start making changes and then understand what changes, measure the data against the changes that we've made to see actually are we improving based on that change. Now, the other thing about this retail is that it's very much like try before you buy. So you can just come and look at a product and we don't really care if you buy it there or not, but you can actually then go online and buy it, or you could buy it in the store. Now, the other thing about this store is that it's quite dynamic. So we know retail, instead of it being dead at 6 p.m., how do you change that around? We can flick this retail space into a workshop mode in 15 minutes. So the tables that show the product actually have all these chairs inside them. They've been turned around into a workshop mode. The shelves slide over into whiteboards. So now it's a fully interactive space. So again, how do you take a retail into a second mode? And then this could be in a third mode, which is events mode. So we have, we're going to test all this as a multi-use space. And so when it's quiet during the, say, 5 p.m. time, we can change it into an event or a workshop mode. So that's going to be launching soon. So we'll be able to tell you guys more about that later on. Another project that we're working on is just on our flat roofs. So we have...
Sorry, Karan, I don't want to interrupt you. We want to leave a few, some time for questions. So we're trying to kind of...
I'll wrap this one up in 20 seconds. So we're looking at flat roofs and we have our landlord on board. So we're basically looking to see, can we take this underused, utilized flat roof and bring it into something that can work on surface water attenuation? How do we absorb CO2? So we're working with UCD, Cora, CHQ, Wire, and we're going to see what sensors we can deploy and take it from maybe just our point to other buildings around based on load, and then see, you know, with all these buildings within the district, you know, we estimate that there's equivalent of the St. Stephen's Green on flat roofs in that area. Then next thing would be really taking all of what we've learned and then helping the other towns and villages around the country to go, here's what we've done in Dogpatch, you could do that in your startup hub or in your town. So that's it from me.
Thanks very much, Kieran. So, so this concludes the presentations. We're running quite a bit over time.